All right, good afternoon. It's for me, everybody. Welcome to the session on GitHub Actions and Security. My name is Rob. I'm a DevOps consultant in the Netherlands. I work for Experience there. And I've been using GitHub Actions since it came out in 2019. I want to give you a deeper dive into the security aspects of using Actions. Because when you start working with them and you work with them in your real world day-to-day scenario, in your continuous integration or deployment pipelines, you must also take care of the security in and around your pipelines that you use to build and deploy your code. So in this session, we'll go over some of these security aspects here. For example, what happens when your pipeline runs? Who has access to change the code in your repository? Or who can get access to the keys and use them to create new resources in your cloud environment? All security aspects of using GitHub Actions for your CI/CD pipelines. We'll go over these and I will show you what to look for and where you can find security things inside of GitHub and improve your security stance without blocking every DevOps engineer in your team. For this session, I assume that you at least know a thing about about Git and GitHub itself. And I'll go straight into GitHub Actions. There have been two different sessions on NEC London as well, discussing things on how to work with GitHub Actions. So I'll assume that you at least know a little bit about it. If you really have a question, then let me know, and I'll try to clarify. In the lower left-hand corner, you see my Twitter handle. If you ever want to reach out, use that one. That's the way to get a hold of me. And I'm always happy to dive deeper into the questions that you have. I always like to figure those things out as well. Taking a step back, let's start first with what are GitHub workflows, because we're not just talking about GitHub Actions, and that's the thing that's being marketed, and I find it a little bit confusing. Just wanted to be clear about it. The workflows are the things that are actually executing your actions. They can be triggered by different events, like a push to your repository or a comment on an issue, or when you do a release and stuff like that. And those are the things that handle the execution of the action itself. The actions then are the steps in your workflows. So it's not just GitHub Actions. You can trigger a workflow and something runs in it. In the basics, you can run any shell script that you have and do something in there. But you can also use GitHub Actions that are basically a precompiled version of a shell script for you. You can create your own, or you can use an existing one from the marketplace. Last time I checked, there are over 6,700 results in the GitHub marketplace. So usually there's something there that's available for you to use. So you don't have to reinvent the wheel yourself. Looking at a workflow example, in case you haven't seen it yet, the workflow is a text-based YAML file that will always need to live in the workflows directory. Last night I created one in the workflow directory and I couldn't figure out why it wasn't working. Until I remembered that it really needs to be the .github/workflows directory. And you store them there together with your source code. In one place, so you have all the opportunities to use source control there as well. The workflow is triggered on an event. You give it an event handler like this, saying when somebody pushes code into the repository, this workflow will be triggered. And it consists of one or more jobs that are a group of certain actions that are doing something for you. The actions themselves are listed under steps, and this is the de facto action that everybody, of course, uses, because you need to check out your code onto the action runner when you start doing things, because you want to do something with your code. And the next one is an example of setting up .NET Core on the runner that is executing your action. I will talk more about runners in the next section. In this case, is setting up .NET Core on the machine itself with a specific version. And then lastly, I'm actually doing something with my source code, and that's building the .NET application that is in there. So that was just an example of what a workflow is and what are actions, because I will mostly be talking about workflows. The key takeaways for the session are listed here. We'll start with repository security and all the aspects that you need to think about there as well. It's not just your actions that you need to think about, but also the runners that are executing your actions, the actions yourself. And then we'll go over some best practices like forking the actions and making sure that you keep up to date with any incoming changes. For repository security, I want to dive into three different topics: the access to your code, the workflow secrets that are in your actions that can be used, and your own code yourself, because you really need to think about that as well. So looking into the first one, think about who has access to your code. Those access levels can either be set at the repository level, where you limit access for a user to only the repository. You can also set it at the organization level and set it for all the repositories in that organization. And then next you have the enterprise level, where you can set it for all the organizations and all the repositories in them. One of the best practices here is when anytime you do something with security and giving access to certain users, don't give a user a specific access to a repository, but always use a group of users. Inside of GitHub, those are listed as teams. And you can even nest teams in teams to make your life as an admin a lot easier. So that's a common best practice to follow. Looking at the permission levels inside of GitHub, and it goes of course from you can have completely no access and to read-only access. If you are a registered user on GitHub and you're logged in and you go to a public repository, you always have read-only access to the repository. One level up is triage, an extra level that they created to, on top of read-only access, give somebody the opportunity to manage issues and pull requests and do something there with them, so they can triage the incoming issues and pull requests on the repository. Write access is of course rather clear, and the maintainer has a little bit extra access. For example, they can edit the repository description or enable the wiki for the repository, so they have a little bit more extra options. But they don't have any access to sensitive actions, like, for example, viewing scanning alerts from security reports. They can also not delete, transfer the repository, or delete packages from the package store. So that's a nice level in between the full admin that has access to everything inside of your repository organization and write access. If you want to know how to find those things, when you are looking at an organization level, and you're looking at a page for Global DevOps Bootcamp, an organization that I'm part of, you can go either to the Teams tab or the People tab and find the members of your organization there and see what rights they have and add them to Teams if you want to. When you're doing it from a repository perspective, when you're in the repository, it's listed under Insights. You can go to people there as well and see who has access to that specific repository. And either change them or remove them if you want. Nice thing that GitHub has is also an availability to look at it from the user perspective. This is my GitHub tag, where you can go to the user itself and then reverse look up to all the organizations they have access to, all the repositories they have access to, and all the teams that they belong to. For example, in this organization, I'm part of 2 teams, and I can access 81 repositories. It also lists here that I'm an owner of the organization itself. So immediately you get an overview of what this user has access to inside of GitHub. And lastly, you can even see the repositories themselves and then manage the access on the repository level if you want. So it's a really good way to figure out what a user can do inside of your organization or repository and maybe then manage the access for it. Right, so that's who has access to your code. That's the basic setup inside of GitHub. Let's look at workflow secrets. If you have used actions before, then you know that you can include workflow secrets as well. You can create them either at the organization or repository level and then rather easily use them in your workflow. In this case, I'm pulling in a secret, name the publish profile, and GitHub injects that for me when the workflow is being run. The nice thing about workflow secrets, when you start looking at them, is that they are always client-side encrypted. They're encrypted with a public key for your organization or repository, and that's created and stored by GitHub, so you don't need to worry about it. And UI even uses that, it downloads that token, and before you post the data back to GitHub, it will encrypt the secret, so it's really a secret, and GitHub doesn't know what's in the secret. But they know that it's encrypted with the public key, so they can decrypt it with that as well. When you post it to the REST API, you also need to be aware of that and do the encryption client side. This gives you enables you the option to start posting the secrets and making them short-lived through the REST API. One good thing to know, especially when you have public repositories and somebody can fork them, they only fork the repository, the Git repository inside of your project. They're not getting access to your shared your secrets. So it's a good security level to be aware of. So if you're looking at secrets and start thinking about it, those are relatively safe. When somebody forks it, they won't get access to your secrets. Looking into who has access to your secrets, if you look at the repository level, then you need to be repo owner. And if you are creating them at the organization level, you need to be admin for the whole organization, because you are creating a secret that all the repositories in that organization can use, of course. The nice thing that the org level gives you here is you can set an access policy to the secrets. You can say the secret is available for all the repositories in this organization. You can say it's only available for private repos, or even just a specific set of repositories that are given access to. That's a nice extra managed thing that you get when you start using them at the organization level. Going back to those secrets and the security standpoint from them, it's, well, okay, they are encrypted until they are used in the workflow. GitHub injects them as either an environment variable or direct input to your shell commands. They already say that we will try to redact them in the logs. And by that, it means we try to recognize that string in the log, do some regular expression on them, and hopefully we can find it in the log and then replace that with stars so the secrets won't leak out of your logs. That's why they say don't use structured data in your secrets. If it's JSON, it's very hard to detect the full string in the JSON because of the ways that you can format them. So we try to redact them, but maybe we fail at that. So be aware of that when you start using secrets. I have an example of that. And remember, the secrets are injected for the action, and the action can do anything with them. They could send them off to a third-party API, and you wouldn't be any wiser. It also means that anyone with access to the action logs should be considered to have access to your secrets, because GitHub does try to redact them, but that's the best effort. There could be something in the action that's doing something weird with your secret, and all of a sudden, everybody who has read access to the logs, and that is for a public repository, any authenticated GitHub user can have access to your secrets. So, rather scary to use them if you start thinking about it. This is an example of a job that does it with shell. The first one is just echoing out the secret, and that will be redacted, of course, but the second one is doing something specific with it. It's adding a space after each character of your secret. And then all of a sudden, you can see the example here on line 6, it says, so the first one, it's fine, I can redact that, but the second one doesn't fulfill the regular expression they're using, which is, of course, natural because that's harder to detect. And all of a sudden, your secret is now available for anybody who has read access to your repository. So think about that aspect as well. It's best to handle secrets in maybe in a different way. I'll have another example later on. What you also need to think about is the code itself in your repository. And that means anything within your repository. That could be your workflow files that somebody has read access to. The shell scripts that are in there that you use in your pipelines. Your own code is something that you need to think of, and this is a security aspect as well. But also all the dependencies that you're using in your repository. Whether it be NPM packages, NuGet packages, those third-party dependencies, or the Docker containers that you use. Those are probably built on an image from somebody else. And that all those layers in the images could have security vulnerabilities as well. So what you please need to do is at least add linters in your workflow that do various checks to make sure that your code isn't doing something stupid, like maybe echoing out variables into the command log, or doing something like a SQL query injection in your HTML application. But also do a static code analysis on your own code. You might be leaking something out. And hence, think about third-party dependency scanning as well. We now say that, hey, when you start using the code, we're building on the shoulder of giants, you're probably using third-party dependencies from an NPM registry or NuGet. And we say now that, hey, remember that 99% of your own code running in production is not yours. We are building on top of the work of others. So scan all those dependencies with known vulnerabilities. There are a lot of tools available. There are different sessions about the topic, so I won't dive too much into that. But make sure that you check them for known vulnerabilities. There's an open source, an open vulnerability database available on the internet, and those tools will scan your code and match them with them. And next, at least keep your dependencies up to date as much as you can, because it's much less prone to having fault injections into up-to-date dependencies than dependencies that are 2 years old. All right, some best practices here. Maybe this is everybody already knows that, but if you don't know it, then it's new for you. and that's at least something that I needed to say. Make sure that you prevent changes in your repository by a single user. If you're using GitHub, then you know about the pull request mechanism. Protect your main branch, the branch that you roll out into production. At any cost, I would almost say it needs to be workable, of course, but if you are working in a team, make sure that always another person, hence the 4 eyes principle, at least 2 persons have looked at it, have made sure that there are no stupid mistakes in your code that are so blindingly obvious that will be big. I usually have this in my team as well. And mostly it's maybe fixing typos for me that somebody noticed, but every once in a while they give you a comment and say, I'm very happy that that didn't reach production. But this is a common best practice that we use. Looking into the other parts of your code and repository is making sure to trace any incoming changes. For looking at who made changes to your code, it's very easy. You can go to the Git commit history and do everything in there. But everything around your code is also available inside GitHub. So especially from a security perspective, that's very good to know. You can find all the changes if you are in an organization. If you go to settings, then you auto log and everything that somebody has done in your repository outside of adding code is in here. So if you give somebody access on the repository, that's listed in the auto log. If you are creating, deleting, updating secrets, that's in the auto log. If you are enabling specific features for that repository, it's also available. If you're not in an organization but you are on your user level, then you can go to your user profile, go to settings, and you have the same security log there. It's just named differently. It's in a different place. So this is at your own public GitHub profile. These are your logs as well. So especially for an auditor, of course, this would be helpful to see, hey, who can access the code, who can make changes, for what purpose, everything is in there. All right, so far about the repository. Let me get a sip of water. Let's go over the next part and talk about the runners and the security aspects of them. As I already said, the actions are being triggered and the actions are then executed on runners. On the top right-hand side, you see this one runs on Ubuntu latest, and on the bottom one runs on self-hosted. Those are the default tags that GitHub uses to differentiate between GitHub-hosted runners and self-hosted runners. The top one is hosted on GitHub, that's the default tag that they use. Just use the latest Ubuntu latest setup, and on top is the default label that they use for running it on self-hosted runner. Using a GitHub-hosted runner here gives you a lot of extra stuff out of the box. All the things that are installed on the runner are GitHub's responsibility. They are responsible for keeping the OS up to date, and all the tools that are pre-installed on those runners. For example, Python is pre-installed, .NET is pre-installed, all those stuff is their responsibility to keep it up to date. And they have a good track record of actually doing that, and they also start removing versions that are no longer have long-term support. This morning I saw a report that they were removing the basic .NET 3.0 code from the runner. You can still install it afterwards if you want to. But that's all GitHub's responsibility. Depending on the package that you have with them, you get a set of 3 minutes, and after that has been expired, then you start being billed by the minute that you're using GitHub runners. They also make sure that it gives you a clean environment for each run. And as you'll see later in the session, that's very important. But if you, for some reason, have some software that you need to run, or you want to run it on a GPU-enabled setup, then you could create your own runner. And it's very easy to do. But that means that, well, you can run it anywhere where you want to, but it also means that you are now responsible for any security aspect on that runner. You need to be aware of that. You need to make sure that the OS is up to date, and do every once in a while do an audit check there and see what's in there. But it gives you the opportunity to have a specific setup that you need. Maybe it needs to run within your firewall environment because it needs to access some licensing server for something. You can do that with a self-hosted runner. Of course, additional benefit is you don't pay for the execution minutes that you need that runner because you're already hosting it yourself, so there's no fee involved on that part. You pay for the OS and the machine anyway, but that's good to know. The runners themselves, they're open source. You can look at the source code there. And if you go to, if you have the access level to install them, you can go to the page in GitHub, and they make it very easy for you. Run this script, download the zip file from the official GitHub release folder, unzip that file, and then start a configuration command. That points back to your repository. You give it a security token. Those tokens are always generated and only available for an hour, but I wanted to redact it here anyway. And you even can retrieve those tokens with the GitHub API, so you can automate the spinning up of hosted runners as well. That's good to know. When you install a runner, you can go to an overview inside GitHub, find all the self-hosted runners, and you can see the tags in here that each runner has. In this case, it's running on my machine, self-hosted. That's the default tag that gets immediately recognized that it's running on Windows x64. So they add that label as well. Good point to note is that for GitHub runners, you don't have to update them yourself or by hand. They do that automatically whenever a new workflow is executed on them. They check if there's a new version of the runner. If so, they will download it and install it. Unless they don't have any work for a week, and then they will automatically install it themselves. What the runner does after it's been configured and starts running, it starts a long calling connection out to GitHub, asking, hey, do you have work for me to do? And then backing off for a minute if there's nothing that they need to do. And keep in mind, it's an outgoing connection, especially now in these days. Any sysadmin that is worth the time, I would say, will not allow you to have an incoming connection through your firewall, of course. So it's helpful that this is an outgoing connection. And it's also not something that will generate a lot of traffic on your network. It's an outgoing long call connection where it really says once again, hey, you have work for me to do? Nothing? Okay, then I'll back up. You can create the runners at the 3 levels again. You can create it and dedicate it for a single repository, or enable it on the organization level, and then all multiple repositories in the organization can use it. Or you can even set it up for the enterprise, and then all the organizations in that enterprise account can use it. Security-wise, you need to start thinking when you install them, hey, it's now your responsibility, what parts of your environment you want to have access to. Not only on the disk itself that it's installed on, but also on the network that it can go out to. So really, never give it an administrator level account, or even worse, a network administrator account. Tighten everything up around that user and make sure that it only can do on the machine itself. You don't want to have it just going out to a network disk and writing stuff there when somebody else is using that same network disk. So really think about the scope that the runner has access to and limit it as much as you can. In a way to limit the access that it actually has is, for example, running the actions inside of a container. This is an example of a job that configures a step. And in this case, the step is just running a container. Then at least you're bound to the container level around anything that it can do. And the security threats there are a little bit lower. You can also do that at the whole job itself. So this job will run inside of that container. GitHub will then spin up the container for you. And they will mount a volume to the container where all your source code is in. And then you can use the actions that you want to do inside of the container itself. So this is also a security boundary that you can add when you're running your actions. One very important tip, and this was also in the GitHub documentation as well, it's a best practice: never, ever, ever use a self-hosted runner public repository. It's very important to understand that. And this is also the reason why GitHub gives you a clean environment on the hosted runner within each run. For example, you could have your repository and you say, hey, when somebody pushes in new code, I want to run it on my public, for my public repository on my self-hosted runner. Somebody creates a new fork, they add some malicious code in there, and then they create a pull request for your repository. If you have an action workflow running on your self-hosted runner, it will just run that code for you. Very nice. Until they do something malicious on it. Same thing with persisting data between runs. Monitor first run downloads your dependencies, builds your code, and then somehow overrides the dependency cache on that machine that you're reusing perhaps for your entire organization. Because hey, it's easy to have a dependency cache centralized, then everybody can hit that cache. Somehow the process in the workflow has access to the dependency cache and maybe could override. Well, then the next run would start up, use the cache dependencies, build the code again, and now all of a sudden, without you knowing it, you have a malicious dependency as a build artifact. We've recently seen that as a supply chain attack with the SolarWinds setup. If you want to dive more into that topic, I recommend that you read that blog post. It's very interesting to see what has happened there, and by just injecting one single DLL into a build pipeline, that the next step will pick that up as an artifact and deploy it into production. And now maybe you've seen it, then you're probably very much toast. So very interesting to see what it does. So that also gives us the best practice. Don't share your runners and the machines they're running on between repositories. Make sure that everything is running on a separate environment so that the first run has the least amount of influence that we can have for the second one. Already mentioned, you have the risk there of malicious programs running on your machines. Maybe you could even escape to run a sandbox. Not everything is 100% secure. You cannot get it 100% secure sometimes. And you might be exposing access to your network environment. So segment them off as well from your production stuff as well. And then it could persist the unwanted or dangerous data on, for example, your dependency cache, or maybe even on the machine itself. Maybe even the process on the runner has access to your private SSH keys into your production environment, or API access tokens that they can read from your environment variables. So think about that as well. Same thing goes by the workflows that are being executed. Well, what happens when somebody pushes code into your repository? What are the workflows that are triggered and by which branch? Well, I've tried looking into that and figuring out if I could give you an easy way to see what actually happens, and I haven't found a good solution yet. So if I, as an external, would be looking at your GitHub organization, or I would be an auditor, then this would very much be the starting point of my investigation. Hey, what is actually happening when somebody pushes code to your repository? All right. That concludes the runner part at least, and hopefully you will start thinking about it before you install a self-hosted runner just inside of your network. Let's look into actions and security. I already said actions can be coming from the marketplace, which you just install any code from the internet, especially if you're running in an enterprise. You want to know what it's doing inside of your network. I find this stuff very scary. Now, as an example, you can use the actions from find them on the marketplace, or go to the direct URL for the actions themselves. If you go to the marketplace and click on the use latest version, you get a pop-up that says, hey, you can use this action by using this users part in the workflow YAML. And that first part is just the direct URL to the organization and the repository that the code belongs to. So you can even use the direct URL, and nobody ever needs to know if it's even available in the marketplace. As I already said, you need to think about those attack factors, not only data theft, like your API tokens being stolen, but also the data integrity breaches. That a malicious action modifies one of your build artifacts and injects something in there. But also think about availability, especially if you're in an enterprise. Or if you're putting in an action that somehow pulls out into the internet, and when they think it's the right time, they will crash the action on purpose, and then all your workflows are stopped from being run again. Maybe you could even crash the runner that you're using. As you see with the sophisticated attack these days, that could be a real possibility, especially when you have a high vulnerability running in production and somebody has the opportunity to maliciously crash the action on purpose, and then nobody can update production with your CI/CD pipelines anymore. So think about those attack factors as well. Any protective measures that you then can use, if you start following the GitHub advisory here, is of course do everything manually. Go to the repository code for the action and check every line of code in there before you start using it. Make sure that you know what it's doing. Try to vet if the maintainer has any reputation that you think you can rely on. But also check all the third-party dependencies that are in that action. If they're using a Docker image, then you need to check all the image layers in that image as well. So that can be quite an extensive task, but it's still up to you as somebody who uses that action to make sure that you look into that. It's your responsibility, and GitHub will not take up any responsibility for that, of course. They say we enable it on the marketplace, and it's up to you to verify and vet if you want to use it and see if it's safe enough. Well, some protective measures then. Going back to the URL is just the name of the action and repository. This is an example of a user who created a totally non-harmful must-have action, of course. If it has an action.yaml, you can use it in your workflow using the direct URL. This one is not on the marketplace. You can see that it wants to have your secret. And you can guess what it does. It will just, in this case, it's benevolent. It will log the secret with spaces after each character. And as an example, that you just can pull in any code from the internet and use it in your workflow. So maybe then, as a protective measure, you want to say, well, only use actions listed in the marketplace. If you go to the repository itself, GitHub notices that you're in a repository that has an action.yaml in it, checks if it is to see if it's listed in the marketplace, and says in big blue banner, you can use this, it's on the marketplace. Well, I went to check into this one, and there's completely no real verification process for it. I published one last week, and it was available within 10 seconds. I've heard through rumors that they do at least some checks. If you have a Bitcoin miner in there, they probably will be flagged and will not be listed on the marketplace. But there's no real verification process for it. Anybody can create an action, push it to the marketplace, and then you're good to go. So using this one as a protective measure isn't that good of an example in my opinion. Next level that GitHub gives you is the verified creator label on the actions, and then it's the creators itself. They say that, hey, GitHub is verified, this action was created by that specific user. I thought, well, maybe this is then at least something that means something for me as a user. And unfortunately, I cannot find anything that enables me to become a verified creator. The only statement that you find is that the author is a partner that GitHub has closely worked with. And don't state anything else. So I don't need to know what it means. Do I need to have a GitHub repository or account for a year? Or do I have a lot of actions in the marketplace? I have no clue. So this is another protective measure that is being mentioned in the documentation of GitHub themselves, but I wouldn't use that because it doesn't tell me anything that I really need to know about it. What else can you do? You can go to the repository or the organization and you can limit the actions that can be used inside of that organization or repository. When you use these limits on the organization level, they are for the entire organization. So there's not, it's not the case that you can then go into a repository on the organization and switch it around because you want to have more access. These are really limited at the organization level. You need to be an admin or at the org level to set them. So it's a big impact that this could have. You could, for example, say that I only allow the select actions, for example, by creators from GitHub or by verified creators. Sorry. Well, the ones from GitHub are probably safe because GitHub host them during the /actions repo, so that is rather safe to use. But as already said, the marketplace actions by verified creators, for me, that's not good enough. You can also say only allow specific actions that are listed. In this case, I said with my user token, I created a different organization. I said this is the organization that I will put all my actions into and only use actions from that specific repository. That gives me the opportunity to only post actions there that I really want to use, and I can vet the code in there and make sure that everything is okay, in my opinion. And that could be a comma-separated list that goes on and on. You can pull in all the actions you want, but this is as an administrator. This is a part where you can say only allow those specified actions. And if you then use an action in your workflow, push it into your repository, and there's something that is falling outside of the scope, you'll get an error message. In this case, I'm using the curl option from the user. That's not in that setup, and it nicely tells me, hey, you can only use them from the matching wildcard setup, only from my organization that has actions in them. What else can you do? You can also look at pinning a certain action. You can either pin it, all the actions are following semantic versioning, so you can say only production versions, pin it at the minor level or the major level. That's a rather common thing that everybody advises you to do. But I went looking into this and I found out that those tags are either added manually on top of the release or automatically added because the release has a tag in it. And the release tag comes from the Git tag. And when somebody changes the code and pushes the code back into your repository, they can reuse the same tag. So pinning it with a tag doesn't tell me anything because the code can be changed between me verifying the version with that tag and later on pulling in the action to the workflow. The best practice here is to at least pin the commit SHA for the action. The commit SHA is completely immutable. It's generated from the code that is actually in that commit, and it cannot be changed. It's very hard to have a SHA collision. It's nearly impossible sometimes, especially with the same organization repository link in there. So this is the safest way to use the commit SHA, verify the code in the action, and then use the commit SHA for that version. Then you will at least know that this will always be the same code that you have verified before you started using. All right, if I then say only allow local actions, look into that as well. And some recommendations there. When you start set up the action organization, only limit it then to local actions and fork all the action repositories over to your own organization. That means that you have had an opportunity to verify the code that's inside of the action that's being used, pull it over to your organization, and nobody else can then touch that code anymore. We don't have to use SHA tagging then with SHA, but you can say only limit the organization use of actions to that specific set of repositories. And when you do that, I don't want you to block every DevOps team member because they really want to have the autonomy to test everything themselves. Also create a separate organization and give them the opportunity to test repositories in there. Give them the rights to fork the actions in there, have some test verification scripts there, and have a process that defines when the forked repository can also be forked into your production setup, the organization where you say only that can be used for our production repository. All right, that concludes the actions and security part. Let's talk about forking those actions a bit more. Forking the action is the actual best practice. What you now see is that everybody starts talking about use the GitHub Actions and do something with them. And when they started releasing the actions in 2019, the first thing they said was always fork the repository, pull in the source code locally, and have an opportunity to verify what the action is doing. These days I see everybody skipping over that part. And that means that you're just pulling in any code that's lying around on the internet, and using that for production setup is not very good in my opinion. So fork the action to your local repository, and then limit the actions being used in your organization or your user account to only the local actions that you have forked. That at least means that you have the opportunity to review the code. And it also has some extra benefits. It's not only more secure, as I already explained, but you also have a backup of the action code itself. In the case something happens, a maintainer is being moved to a different repository, somebody hands over the access keys for the GitHub repo, then you still have a backup of the same version and you know what you're running inside production. This also, of course, helps with making sure that your CI/CD pipelines can actually function when you need them, and not that somebody else drops a package or an action somewhere in between and everything is broken again. The negative side of that is that it also means that you have more maintenance work. You need to create forks, you need to have an organization to do that, and you set up the rights for that. And not the last thing is you need to make sure that you keep them up to date. A maintainer might find an issue with an action, a vulnerability in there, and updates them. But you need to have a process there of finding out when you're out of date and verifying the code again and putting that in. We'll show that next. This also limits the usage of new incoming actions because you need to have that process set up where your DevOps team can go into the action code itself, verify it, and they make the conscious decision to say, hey, I've looked at it, it's safe enough, let's start using it. So it's their responsibility now for enabling it and verifying it. So it gives you more maintenance work. But from a security perspective, I think you really need to take on that extra work because it's your responsibility for the stuff that you're buying in production. As I already said, be aware of setting it at the organization level will block your entire organization from doing anything else. So create a test organization that teams can use for testing and finding new actions. Otherwise, it will be completely blocked and pulling in code, and you need to do that somewhere else, and they probably will do that on their own user account outside of the scope of your organization, perhaps. All right, looking at the time where we are, let's talk about keeping everything up to date. Not just the forks, but everything around the marketplace as well. The thing is, the actions are actively maintained. It's very hip right now. Everybody's looking into them. If you really start looking at it, you see owners of repositories, maintainers of actions, continuously updating the actions and enabling more features, adding more parameters. And it's now up to you to make sure that you stay up to date. There is nothing like a real deprecation message inside of GitHub that tells you that, hey, there has been a new version release of this action. And perhaps the maintainer can inject that in the logs, and hopefully you catch it in the logs. But if you catch an updated version in the logs, that means that you're probably using version pinning, because they then have published the same version with a deprecation message in it, and you're not using the commit SHA. If you're using the commit SHA, they cannot update anything inside your environment. So how do you stay up to date? How do you then update, for example, the forks that you created? How do you read the changes that are in the source repository being made? Because you need to reevaluate the new version as well. So staying up to date, I had the same issue and I was very interested in this. So I created a GitHub bot, a Twitter bot that reads the GitHub Actions Marketplace every couple of hours, finds out if there are new actions and sees if there are new versions, and at least tweet those out. So I see them fly by in my social media stream. And I find very interesting stuff in there. Last weekend, there was somebody who was programming in the weekend, and they thought, wait, maybe that's not such a good idea, and I created an action that would prevent any workflow from starting in the weekend. As a mental health safety thing, they want to promote. So you find little gems like that as well in there. So this Twitter bot posts at least about those actions and the updates as well, because there's no other feed that I could find that gave me that information. What you can also do is go to your repositories. When you go into, in this case, I'm in my actions organization for a test repository, you can see that it's forked from my user account. And you can see that, hey, this branch is 2 commits behind. You can compare it and even pull in that code. You could try to update all your actions like this, but that would be very cumbersome if you have a large organization with a lot of clones, forks of actions in them. And if you have them, then you could all do all the updates yourself. Or you could say, well, hey, I'm a DevOps engineer, let's automate this process as well. And these are the basic steps that you need to go through. And if you want to find more information, go to the gist that I created. It's rather simple. Add a parent repository as a remote, then pull in all the changes, merge those changes back and push them to your repository. But there are, of course, better ways to do that. For example, you could use a workflow there for that. There was a user that created a specific workflow that would sync any fork with an upstream or parent repository. But the downside here is that you need to add it each repository, so each fork, and you need to add it on a specific branch, because otherwise you're polluting the main branch that you want to update, and then it will be very hard to start updating that. That also means that you have an issue, because GitHub in the current setup doesn't work for any workflow that's not on the default branch. It's harder to test those things. You cannot just see the logs if they haven't executed, and you can only execute them through the API. So that's still hard. But this also still means that you're pulling in all the incoming changes without giving you an opportunity to review those changes. So it's very nice to have a scheduled workflow that does that for you, but then you're still pulling in code from the internet blindly. So in my opinion, that's still very scary. So I started looking into, is there any better way to do it? And I couldn't find anything. That's too bad. But I'm a DevOps engineer, I'm a nerd and I like these things. So I created a repository that does that for you. You can fork this repository and then it will automatically update stuff for you. And I have some slides here in case that it doesn't work, but I'd rather demo that live to you on GitHub itself. I think that's more interesting. So let's see if everything still works. GitHub Actions did have a production issue this morning. So if everything has been set up all right, you can see my GitHub environment. This is my my user account. I have the fork updater in here. When you fork that other fork updater into your own organization, let's see if we can make this work fast enough for the demo, but probably we should be fine. I'm going to fork it over. It's not that large of a repository and set things up. First thing that I need to do is when you create a fork, the issues will be disabled because, of course, you want to create issues in the parent repository and have them fixed there. And they set that out, blank that out, so I can re-enable the issues part because I'm using issues for this setup. I can also go into actions. And since this is a fork that has actions in it, there's another safety measure that they take. Those actions will not automatically start running for everything that you do. So you need to say, I understand the risk here, I have verified the workflow code, and that's enabled. Well, I created it myself, so that's easy. And then there's a check workflow that will run based on a schedule. I think it's running somewhere 2 in the morning. And you need to enable that as well before GitHub will start doing anything for you. I don't want to wait and have you wait until 2 in the morning, so let's execute that by hand on the main branch now. What's happening now is that this workflow is starting. We'll go through all the repositories in this organization, check if there are forks, and if so, check if the parent repository has any incoming changes, and if so, it will create issues for those incoming changes. Then I need to do one more thing, and that is making sure that I have a screen here that gives the workflow an option to actually do things. And I'll do that on my own screen so that I won't blur out my secret. Then I'll switch back. Just copying over the right name before I make any typos. Okay. I'm going to switch right back so you can actually see something. Yeah, I created the secret that has my personal access token in there. And by now I was expecting to have some issues in here. Let's look if the action is still running. It is still running. Last time I checked it was faster. Let's see where it is. And then maybe the production stuff that GitHub had this morning is still running amok. This usually takes a minute or so. We've got 3 minutes left. I think I'll switch back to my slides. Unless this goes really fast. Yeah, it's already running. I'm expecting that it's creating issues for me. Let's use this test repository that I have. And you can see, hey, you get a notification if you have the notification set up. There's an issue created where you can find the original fork repository and go there. And if you do that, you probably see that there are incoming changes. You can go to the compare link. Let's see if I have it, and find all the changed versions in there, so you really can review the incoming changes that you want to put in. Apparently, there's been a workflow added. The README has been updated. There's a Hello NDC London message in the README here as well. And after you have reviewed all the incoming changes, where it says label this issue, because I like to use labels for that. In this case, it's a new label in this repository. And when adding a label, another workflow is being run in the background. Let's see if that triggers fast enough as well. And this workflow will then pull in all the incoming changes into your fork repo. So this gives you an opportunity to have a very lightweight process. It's a repository that you can fork and set things up, of course, in your account. So you have everything reviewed in there as well. And then you have a central repository that gives your engineers the opportunity to see what actions need to have updates. You can see it's now starting to run in the background, or the fork has already been updated and the action has been closed as well. So here you have an end-to-end process that enables you to keep track of the incoming changes and update the forks as well. So that gives me the opportunity to skip all the slides that I had for in case the demo wasn't working. And that concludes this session. We talked about repository security and the things that you need to look up and where you can find it. I've mentioned the repository of the runners themselves and the security aspects of that as well. We went over the actions, how you can use them and how you can pin them to specific versions. And the best practice there, if anything is your takeaway for today, is fork the actions and make sure you keep everything there up to date. I've got a summarization slide here as well with all the best practices that I mentioned before. Given where we are by time, I'll skip over that. I'll share the slides afterwards anyway, so you can reread them if you want to. And with that, I think we're at the end of this session. So thank you so much. It was a blast for me figuring all this stuff out. If there are any questions, feel free to unmute. We've got a couple of minutes left before the next session starts. And otherwise, ping me on Slack or Twitter. I'm very open to feedback and any things that you have thought of. Maybe I can do the update part better. And maybe you have a different process that you use inside of your organization. We'd love to hear about those things.